sure you guys copy this on your notes, and that's fine. We can just do it on the left side of your notes. Let's cover the atom. You guys went over this in chemistry class, and whenever you look at the periodic table, the top number will tell you the atomic number, or the number of protons and electrons. So hydrogen has 1 proton, 1 electron. The bottom number, notice it's a decimal, and we're going to cover why that is later on today, or in this video. And the decimal is supposed to be an average of all the different types of isotopes and all the different types of hydrogen atoms that are out there. So this is the number of protons and neutrons. Okay. So if you look at lithium, lithium has 3 protons and 3 electrons. The plus and the minuses have to be the same. Okay. The neutrons are the ones that can change. So here, if we just round 6.9, let's just round it to 7. Okay, pretty simple. So if you look at magnesium, and on the periodic table, notice on the periodic table you'll have the numbers on the top, the atomic number and the atomic mass on the bottom. It's got the decimals. Okay. So here if we look at magnesium, which is over here, 12 and 24.305. Magnesium has 12 protons and 12 electrons. The neutrons we're going to round and we're going to subtract. 24 minus 12 is 12. Let's look at phosphorus. Protons and electrons have to be the same. The neutrons, we're going to round 30.9 to 31. 31 minus 15, 60. Chlorine. Protons and electrons. Protons are plus, electrons are minus. 35 minus 17. 35 minus 17 will give us 18. And iodine, 53 protons, 53 electrons, and we're going to round that to 127 minus 53. It gives us 74. So let's take a look at the handout that we are going to be doing today. So you're going to have to copy down the table, and you're just going to fill in the missing parts. Okay? So once you copy it down, for example, the chemical symbol for oxygen, so we look at the periodic table, the chemical symbol for oxygen is O. So O. The protons and the electrons are the same, right? Protons. So if we look at the protons and electrons, it is the top number, 8. Protons and the electrons, and that is also the atomic number. Okay? So these 3 right here, they're always going to be the same number. The atomic mass is the number that is on the bottom. And we can round. And the number of neutrons is, we're going to subtract 16 minus 8. That's going to be 8. Okay. So if we look at carbon, carbon's right here. 6 protons, 6 electrons. That's the atomic number. 6 protons, 6 electrons, and that is also the atomic number, right? These that I circled are going to be the same. The neutrons, or the atomic mass, let's do the atomic mass first. The atomic mass is the bottom, 12. How do I get the neutrons? I subtract these two numbers. 12 minus 6, 6. Okay. And there you go. You're going to pretty much do the rest. So remember these that I circled, they're always going to be the top numbers. So sodium, for example, sodium is right here, sodium, 11. 11, 11, 11, and so on, okay? You guys can fill out the rest. Now the bottom part, the missing atomic numbers, write the atomic numbers in the space in the grid below to match the clues. Use a periodic table of elements to help you. When you have completed the grid, you will have produced a magic square. By adding the numbers horizontally, vertically, or diagonally, you should get the same number. So here, we're looking for the element to the left of Si. So when you look at the periodic table, there's Si, it's to the left, right? And you're gonna get the atomic number, 13. So you're gonna have to make a little square, 4 by 4, and then we just write the number 13. So if we take a look at the next one, element below the element H. So here's H, the element below is lithium, and we're gonna write down the atomic number, 3. 3. Once you fill out all the numbers, okay, what you're gonna do is if you add up all these numbers here, if let's say you get, I don't know, 70, okay, all the numbers going down here should be 70. You add up these, they should be 70, 70. If you add them going this way, they should be 70. If you add them up going this way, they should be 70, okay? So this is how you can tell if you did it right. 70 is not the answer, okay? I'm just letting you know that once you add them all up, that's what you're gonna be getting, okay? All right. Moving on a new section in your notes. You can copy this on the left side. So now that we know how to find the atoms, now it's putting everything where it's supposed to go. Where do the protons, neutrons, electrons go, and so on? Well, the protons go in the middle, right, in the nucleus. Remember the plus and the minus, the protons and electrons, they will always be the same number. It's the top number. So hydrogen, for example, has 1 proton and 1 electron. Okay. Let's do another example. Here we have helium. Helium has 2 protons, 2 electrons, and 4 minus 4 is 2 neutrons. So this is an example of helium. Lithium has 3 protons and 3 electrons. The electrons, only 2 can fit in the first ring, 8 can fit in the second ring, 8 can fit on the third ring, okay? So we need 3. 1, 2, 1, 2, 3. 3 electrons, right? Neutrons, we're going to round. 7 minus 3, 4. Okay, phosphorus. 15 protons, 15 electrons. So remember, 2 can fit in the first ring, 8 can fit on the second ring, and up to 8 can fit on the third ring. So how many electrons did I put already? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. 31 minus 15, 16. 16 neutrons. And here we have phosphorus. Calcium. 20 protons, 20 electrons. So 1, 2, 8 can fit on the second ring. 8 can fit on the third ring. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So the protons and electrons, they are the same. The neutrons we subtract. 40 minus 20 is 20. Okay, so if we take a look at the handout, here we have the handout, you have the atomic number and the atomic mass, 1632. So we have this example, right? You're going to do exactly the same thing. Okay, sulfur, 16 protons, 16 electrons, 2 fit in the first ring, 8 fit on the second ring, it's 10. 11, 12, 13, 14, 15, 16. There we go. And the neutrons, 32 minus 16, 16. So that's how you're going to be doing the rest. And another thing that we are going to be doing here is go ahead and copy this down as well. So if you have carbon 12 and carbon 14, what does that even mean? Well, first of all, let's take a look at carbon on the periodic table. And it says on the bottom 12. And then the 0.011, I'm going to go over what that means. Okay. But first, let's say they give you something like this and you have to draw these out. So this is still on your notes, just continue it on the left or right side if you run out of space. So we know it has 6 protons, 6 electrons, 1, 2, 3, 4, 5, 6. And neutrons is 6. Now if we look at the next one, the bottom one here, carbon, 6 protons, 6 electrons, 2, 3, 4, 5, 6. And then we're subtracting the mass here. 14 minus 6, 8. Nitrogen, 7 protons, 7 electrons, 2, 3, 4, 5, 6, 7. 7 neutrons. 14 minus 7, 7. Nitrogen here, 7 protons, 1, 2, 3, 4, 5, 6, 7 electrons. 15 minus 7, 8. Now I want you guys to look at, for example, carbon here. Carbon, the protons on this example and this example, they are the same, 6 and 6. 6 protons, 6 electrons, 6 protons, 6 electrons. The only thing that changed was the neutrons. Right? The neutrons are the only thing that's different, but it's still carbon. Okay, the identity of the element is the protons. So if this changes, then you have a different element. So if we went from 6 to 7, that would be nitrogen. If we went from 7 to 8, 8 protons, oxygen, 9 protons, fluorine, 10 protons, neon, and so on. Okay. The bottom number can change. It's still the same element, but this is called an isotope. There we go. So an isotope is an element with the same number of protons but different number of neutrons. So this is the slide before it. I'm just adding this part right here. You can just copy this part. Whenever you change the neutrons, it's an isotope. Whenever you change the protons, it's a new element. Now, why is that? Well, If you look at the periodic table on the bottom again, I'm going to go over why it's a decimal. The top is a for sure number because you can have 15 protons, 16 protons, 17 protons, and that's the identity of the element. The bottom number, we are learning that you can have the same element, but the neutrons can be different. So how is that? This is on a new section. You can copy this on the left side. So the atomic mass of an element is an average of all the isotopes present for that element. So you can have an element of, like here, of carbon with 6 neutrons or 8 neutrons and so on. So how do they get that? Well, it's an average, okay? So if, let's say your grades for 3 assignments were 100, 75, and 50. So what would be your average? Well, how do you find an average? You add them all up and you divide by that number, right? So 100 plus 75, let's see what our grade would be. And then I divide by 1, 2, 3, there's 3. Right, 75. Your average grade would be a 75. Well, let's look at the next one. What would your average be if you had these grades? 98 plus 75 plus 85 plus 80, 338 divided by 2. Oh, that's not right. Divided by 4. There's 4 numbers. 1, 2, 3, 4. 84.5. Notice that sometimes when you do averages, you're going to get a decimal. It's not going to be a nice whole number all the time. You're going to get a decimal, right? And so if we take a look at the periodic table here, notice that's where these decimal numbers come from. That's because we take all of the different isotopes of that element. So we look at all the carbons that exist and we say, okay, we found this much percentage of carbon has 6 nitrogens. Let's say, I don't know, 70% has 6 nitrogens and 20% has 8 nitrogens. So they average those out. Okay, so how do they do that? That's what we're going to figure out here on the next slide. So you can continue this on the left. So here we have our first example. So magnesium has 3 isotopes. 1, 2, 3. 3 different versions of magnesium with different amounts of neutrons, just like here. Okay, so carbon here had 2. Well, we know that magnesium, there's 3 different versions of them. 78% has a mass of 23. 10% has a mass of 24.985, and 11 has a mass of 25.983. So that's the number of protons and neutrons. Okay, that's their weight. Okay, atomic mass units, AMU. So what we're going to do is this percentage, how do you make a percentage into a decimal? Well, you're going to move the decimal over 2 times to the left. And what I'm going to do is I'm going to multiply these 2 numbers. I'm going to multiply those 3 numbers. So 0.787 times 23.985. And I'm going to write that number down, 18.87. 18.87. Okay, I'm going to do the same with the next number. So let me use a different color so that they can stand out. Those 2 purple numbers. So 10.13 is 0.1013. Okay, so remember, you're going to move the decimal for the percentages 2 times to the left. So 10.13 is 0.1013. I'm going to multiply that. I'm going to multiply these 2 numbers times 24.985, 24.985, 2.53, let's do the last one. So 11.17 is 0.1117 times 25.983, 2.90. Once you have all of these numbers, we're going to add them up. 18.87 plus 2.53 plus 2.90, 24.3. Okay. Now, if you look at magnesium, see the bottom number? If we would have included more decimals, then we would have gotten that exact number. But I just included just a couple, so 24.3. That's how they get those numbers on the bottom. Again, they get all of the isotopes of that element and they add them up. Here we don't have to divide, like over here where we divided our grades, we added all 3 and divided by 3. We added all 4 of your grades and divided by 4. You didn't have to do that because they already got the percentages of all that. Okay, so here, let's do another example. So I'm going to clear this out so that it's not jumbled up. Let's clear it out. Okay, so these circled ones. So we're going to find the atomic mass of potassium. Potassium has 3 isotopes as well. It's the same element, but they found that some of these atoms of potassium might have more neutrons than others. And we know 93% of them has an atomic mass of 39. So 0.9390 times 39, 36.6. Okay, let's do the next one. If we move the decimal over 2 times to the left, we should actually get 0.0002. The decimal was originally right there, but you always move the decimal over 2 times to the left, okay? And we multiply that by 40 times 40, 0.008. And the last one, 5.81. Don't forget to move the decimal twice. The decimal was right there, 5.8, but we moved it 2 times. It's always 2 times to the left. Times 41, 2.3821. And we're going to add up all 3 numbers. And we get 39.011. 39.011. Okay, and it's potassium. So let's take a look at potassium. Potassium. There it is. 39.0. And we ended up getting a 1, but I mean, that's okay. It's 39.0. Okay. I know there's probably a lot more decimals, but that's it. That's how they get those numbers. Okay, it's an average. So for the handout, you're going to be doing exactly the same thing. We're going to give you the percentages. So remember these, you always move the decimals over 2 times to the left, and then you multiply it by the next number. You do the same with the next percentage, multiply it by the next number. Do the same thing with the last percentage. Don't forget to move the decimal over 2 times to the left. And then once you write down all those numbers, you add them up. Okay? And let's do one more quick example. So I'm going to multiply those numbers there. Nope, that's not right. 0.0716 times 6.015, 0.430. I'll just say 0.430. .925 times 7.5, 6.93. And we add this up, plus 7.3. Calculate the average atomic mass of sulfur if 95% of all sulfur atoms have a mass of 31. 0.76 has a mass of that. Okay, so let's get to it. 0.95 times 31.972, 30.37. Let's do this next one. 0.0076. $32.971. And 4.22% is 0.04. And I moved it over 2 times to the left, times 33.967. 1.433. And if we add them up, 30.37 plus 32.0. And if we take a look at sulfur, sulfur 32.0. And the more decimals you put, I mean, the more accurate it'll be, but that's okay. I mean, as long as you kind of get the picture of where those numbers here come from. So the next thing that I want to show you is this little animation here. So here we have, let's say, 1 proton, that's hydrogen, right? If you add another proton, anytime that you add protons, that changes the element, right? If I add protons here, or neutrons, I want you to notice what happens. So here lithium has 3 neutrons, but I want you to notice what happens when I add this 4th one, 5th one. Actually, you know what? Let me do this. Start all over again. Okay, so helium is supposed to have 2, right? Well, let's take a look at the periodic table to see how many neutrons it has. And we're looking at helium 4.0. So 2 protons, 2 neutrons, 2 electrons. Two of everything, right? 2 of everything. Now I want you to notice what happens when I add another neutron. See that it becomes unstable. It doesn't like that. And there are some elements out there, like I said, this is an isotope. Okay, there are some elements out there of helium that look like this, and there are that look like that, or might even be like that. Or there might be some that actually has one less, or a couple less. Okay? Notice it's unstable. So what they do is they look at, like I said, all the different types of helium atoms that exist, and they say, okay, well, helium only has, there's only 3 isotopes that has 2 neutrons. There's another one that has 3, and there's another one that has 4. Those are the only ones that exist, okay? I'm making this up. I don't know exactly how many isotopes there are of helium, but that's pretty much the general idea. They will add all that stuff up, they'll get the percentage, and they'll say, well, the main amount of helium actually looks like the stable version, okay? And there's like I would say 90% of it looks like this. There might be 8% that looks like this, and there might be that 2% that looks kind of like this. And that's where they go in and they get that average. They get that bottom number. Okay? They get this bottom number of, just like I showed you here. Okay? So this brings us to our next topic. So make sure you copy this. You can copy it on the left side, or actually no, copy this on the right side of your notes. So whenever you have these atoms that are unstable like this, they will eventually start losing protons, electrons, and they will eventually turn into another element. Okay, so how does that happen? Well, here some elements release energy in the form of radiation, such as alpha, beta, and gamma radiation. So these atoms, they are gonna get rid of, when they're unstable like that, they're gonna either get rid of 2 protons and 2 neutrons, a beta particle, or gamma rays. A beta particle is a fast-moving electron that comes from a neutron. So where do neutrons come from? Well, neutrons, so you have your protons, which are plus, your electrons, which are minus, and neutrons have a charge of 0. A neutron is actually a proton and an electron squished together. When you have a plus and a minus, they cancel out, right? You get a charge of 0. So the interesting thing about the beta particles is that whenever they are unstable like that, it's gonna, that extra energy that it has, it needs to get rid of it somehow. So how does it get rid of it? It can get rid of it from an electron inside a neutron. So this little guy right here will shoot out, and now we are left with a proton. Okay, so that's gonna change the element. So let me show you what I mean by that. So this, you can copy it on the left side. So due to the radiation that these elements give out, they will decay to form a different element. So here we have an example of radium. And this is the atomic mass. This is the bottom number. Okay, I know I have these flipped over, like if we look at radium on the periodic table. Radium right here. Okay, 88 and 226. I have the numbers flipped. The reason I have them flipped is because we're focusing on the isotope, the bottom number, the atomic mass. Okay, so radium, when it's unstable, it's actually gonna get rid of 2 protons, which is an alpha particle, and radium is gonna turn into radon. So this element right here, radium, is gonna turn into this element. So can copper, for example, turn into nickel or zinc? Yes, it can. Okay, if it's an isotope of that element. So here is another example. Okay, you have iodine. Iodine will actually turn into xenon. So, like I said, these elements, they can turn into any element. And the weird thing is, here you'd think, like here, it's getting rid of 2 protons, and it turns into a lighter element. It went from 88 to 86, right? That's a smaller number. So it went from here, radium, all the way back to over here, radon. It turned into a smaller element. Iodine here turned into a heavier element. It went from 53 to 54. It actually gained a proton. So where did that proton come from? Well, they got rid of an electron from a neutron. So this electron went away. So if it was at 53, now that that's not there, you have an extra proton. And remember, I told you guys that the protons are the identity of the element. So 53 plus one more is 54. It turns into xenon. I know this seems a little complicated, but it gets very simple. Okay, I promise. So let's take a look at this. So just continue it on your notes. Go ahead and copy that down. So we have a choice between an alpha or a beta particle. Okay. So here we have carbon, an isotope of carbon, an unstable version. Carbon is going to turn into nitrogen, but will it get rid of an alpha particle or a beta particle? Well, let's take a look at the bottom number, this number right here. Okay. So don't look at this side. Let's focus on the right side of the arrow. So here we're going to put either an alpha or a beta particle. So are we going to do 7 plus 2 is 6 or 7 minus 1? So 7 plus 2, 7, 8, 9, that would be 9. So that's not happening there. So this one would actually be a beta particle. Okay. So here we have polonium. And we're going to focus on the atomic number. So here we have the numbers flipped, the atomic number and the atomic mass. So here, will polonium turn into lead by getting rid of an alpha or a beta particle? Well, let's add. Don't look at this. We're just focusing on 82 plus 2 or 82 minus 1. Well, 82 plus 2 is 84, so it's this one. It gets rid of a alpha particle. Okay. Let's look at another example. So here we have this element is cool. This is, well, let's look at element number 90. I want you guys to look at the name of that one right there. Look at the name. Isn't that cool? There's an element named after Thor. Yes, believe it or not, it's called thorium. And I mean, he's just such an important Norse mythological character. I know Marvel made him into a Marvel character, but he's a Norse mythology. I mean, we do have a day named after him. Thursday. Thursday is Thor's day. So Monday is named after the moon. Sunday is named after the sun. Wednesday is named after his father, Odin, or they would call it Woden's Day or Wednesday. And Friday is named after his mom's name. I believe it's Frigga's Day. So they changed it to Friday. Tuesday is Tyr's Day. It's their god of war. Anyway, so there is an element named after Thor, thorium. Okay, I just thought that was kind of cool. So thorium will change into this element. So let's look. So we're not looking at this right side. We're looking over here. Is it 88 plus 2 or 88 minus 1? 88 plus 2 is 90. So yes, it gets rid of a alpha particle. Okay. 2 protons and 2 neutrons. So let's look at this one. Is it 30 plus 2? 30 plus 2 is 34. So it's not that one. It has to be beta. 30 minus 1 is 29. What if it's the element that we're looking for? So here we want to do 2 plus what number is 85? 2 plus 83, right? 83 plus 2, 83, 84, 85. So now we need to look for that element number 83. So if we look at the periodic table, here we are. Element number 83 is Bi, bismuth. And we do the same with the top number. 4 plus what is 213? And that should be 209. 209, 10, 11, 12, 13. There you go. Bi. Okay, now let's look at this one. What if they give you multiple elements like this? So it's very simple. You're just going to add these up. 4 plus 1 is 5, right? 5. 2 plus what is 5? 3. Now, once you have that, you look for the element. Element number 3. Element number 3, there it is lithium. Right here, okay? Lithium. Now let's look at the top number. 9 plus 1 is 10. So 4 plus what is 10? 6. And there we go. We've figured out what these elements will turn into what. Okay, so here beryllium will turn into plus hydrogen will split off and turn into lithium and helium. Okay? Or actually, this is the alpha particle. Okay? Okay, so what I want you guys to do here is it's the same thing. Okay, you're gonna start figuring out what element each one is. Give you guys a chance to copy these down, and then we're gonna go over them. Okay. So here we have a choice between an alpha or a beta particle. 94 plus 2 would be 96, so it's not that one, it's a beta particle. Gets rid of an electron. When it gets rid of an electron, it actually gets heavier because the electron shot out from the neutron. The neutron turned into a proton. Okay, we're trying to look for the element here. 2 plus what is 83? 81. 81, 82, 83, yes. And then now we look for element number 81. Right there, thallium, Tl. So we need this to equal to 214. 4 plus what is 214? 210. Now I want you to notice this right here. This is a neutron. These guys can actually get rid of a neutron as well. Okay, so how do we do a neutron? A neutron is not an element. A neutron, notice it's 0. So this side is 3 plus 0 is 3. So 2 plus what is 3? 1. So what element is number 1? Hydrogen. Six plus 1 is 7. So we need this side to equal 7. 4 plus what is 7? 3. Let's add up these. 4 plus 1? 5. 2 plus what is 5? 3. Right? This side was 5. 4 plus 1, 5. 2 plus 3 is 5. So what element is number 3? That's lithium. Nine plus 1, 10. 4 plus what is 10? 6. So this one is interesting. Do the same thing. 1 plus 1 is 2. What element is number 2? Helium. 1 plus 3 is 4. What if it's backwards? Same thing. Go backwards. 90 plus 2? 92. Well, that has to be 92. What element is number 92? Uranium. It's right here. Okay. 4 plus 231? 235. And that's how you will answer the handout. It's exactly the same. So moving on, we are going to cover half-life.